Assalamu alaikum. Good afternoon, everyone. Today's topic is about identification of the salt. So, practically, how we can identify a salt. This is very important, and this topic is related to paper 6. So, salt and identification or identification of the salt. So, how we identify a salt? Because whenever you have a salt, the term salt means when hydrogen of an acid is replaced by a metal, the thing which is formed is known as a salt. So, when hydrogen of acid is replaced by the metal, we call that substance as a salt. And for salt it's an ionic compound. These all salts are ionic compound. So when they are ionic compound, they contain two things: the positive ion and the negative ion. The positive ion, because the positive ion they tend to move towards cathode. Positive ions are known as cations, where negative ions they tend to move towards anode. So with reference to that movement, they are known as anions. So whenever you have a salt is an ionic compound which contain positive and negative ions. So there is a test for the positive ion, there is a separate test for the positive ion, and there is a test for negative ion. So test for positive ion, cations, or you can also say positive ion. So this test actually you have to learn or you have to memorize. Last time I shared that file with you. I will show it again, and then basically it's your memorization. You have to memorize these tests. First thing, test for positive ion or cation. How we can test? First, we can test with aqueous sodium hydroxide or by adding sodium hydroxide. Example, if a salt contain aluminium, if there is aluminium ion present in the salt. So if salt contain an aluminium, so what will happen? If you add 5 drops of sodium hydroxide, you have a test tube or a container. So if a salt contain an aluminium, if you add 5 drops, so what you will observe? You will observe white precipitate are formed. So if I say this is the test tube, and this test tube contain a salt, and inside this salt there is aluminium ion, Al plus 3. And what we did, to this we add 5 drops of sodium hydroxide, NaOH. So when we add 5 drops of sodium hydroxide, what we will observe? We will observe white precipitate. And what are these white precipitate? These white precipitate are due to presence or formation of aluminum hydroxide. Just yeah, you join. So basically, if a test is
Hello,
there,
sir.
yes. So these are the tests for the positive ion. If a salt contain an aluminum ion, you will add sodium hydroxide. You will observe white precipitate. If you add an excess, what does excess means? Like you add a lot. You add too much sodium hydroxide. So what you will observe? You will observe the precipitate dissolve, and it will form a colorless solution. Same way, yeah, just I started the class. This is a test for the positive ion. How you can test the positive ion. This is the first thing I'm explaining. This is a test for the positive ion because in a salt there is a positive ion and there is a negative ion. This table you have to learn or memorize, and which is a very important table. So example, if a salt contain aluminum, you have a container or a test tube, and in this container, because the salt contain a positive and negative ion, if the positive ion is aluminum ion, Al plus 3, what you will do, you will first add 5 drops of sodium hydroxide. So when you add 5 drops of sodium hydroxide, what you will observe? You will observe a white precipitate or a white solid is formed. So when the white precipitate or white solid is formed, it means this salt contains aluminum. And what are these white precipitate? These white precipitate are basically aluminum hydroxide. Then in the same substance, if I add an excess means more than enough or I add too much sodium hydroxide. So if I add too much sodium hydroxide, what I will observe? I will observe these precipitate will dissolve and it will form a colorless solution. I have already sent this sheet last class. I'll resend again, but it was sent last week. I'm just discussing this whole sheet because you have to learn or memorize this. Same thing, if you have a lead ion, if a salt contain a lead ion, if you add sodium hydroxide, what it will form? It will form white precipitate. And what are white precipitate? The white precipitate are due to lead hydroxide. And if you add an excess, the precipitate will dissolve and it will form a colorless solution. So basically aluminum and lead are giving the same result with sodium hydroxide. Because some of the ions may give the same result, then there is another way to test them. But in case of aluminum and lead, there is the same result. Same way, if a salt contains zinc, you add sodium hydroxide, you will observe white precipitate, these white precipitate of zinc hydroxide. And if you add an excess, the precipitate dissolve and again it will form colorless solution. So the first 3 elements here you can see aluminum, lead and zinc. They have the same observation with 5 drops or few drops of sodium hydroxide and excess of sodium hydroxide. But if it is calcium, yeah, how you can distinguish? There are different ways, that's I'm mentioning. Not only with sodium hydroxide, there's another test for positive ion. So if you add sodium hydroxide, if it is giving a white precipitate, you cannot distinguish. You cannot distinguish whether, so if I add sodium hydroxide and I observe white precipitate, so what I can say? I can say this salt may have aluminum, this salt may have lead, or this salt may have zinc. So any of these 3 elements can be present. With sodium hydroxide, you cannot distinguish whether it's specifically lead, zinc, or aluminum because they all give the same result. Then there's another test for them. If you are testing, like example, if there's a calcium, when you add, it is giving white precipitate But when you add an excess, the precipitate does not dissolve. So this is a different thing. This is a different thing because here the precipitate does not dissolve or precipitate remain insoluble. So calcium ion, when you add when you add 5 drops, all are giving white precipitate. So you cannot identify. You can also say maybe it's calcium, zinc, lead, or aluminum. But when you add an excess of sodium hydroxide, what you will observe? You will observe the precipitate will not dissolve in case calcium was there. If precipitate dissolve, it means it might be aluminum, it might be lead, or it might be zinc. Same way, if a copper is there, copper 2, when we add 5 drops, we'll observe blue precipitate. And when we add an excess, the precipitate does not dissolve or it will remain insoluble. If iron 2 is there, it will form dirty green precipitate, and in excess, the precipitate does not dissolve. If iron 3 is there, it is giving a red-brown precipitate, and precipitate does not dissolve. If chromium is there, it will give green precipitate, and precipitate dissolve to form a green solution. So you can see here with iron 2, it was giving green, with chromium 3 it is giving green. But when you add an excess in iron 2, the precipitate does not dissolve. In chromium, the precipitate slightly or partially dissolve and make a green solution. And if we want to test an ammonium ion, so what is the test? We add sodium hydroxide and heat. So when we add sodium hydroxide and heat, we will observe a pungent gas which will turn red litmus paper blue. So which gas is this which turned red litmus paper blue? A gas which is changing red litmus paper blue. Ammonia is the gas. Not nitrogen does not have any effect on litmus paper. It's ammonia. Ammonia is the only alkaline gas which can convert the red litmus blue. So this is a test which you have to memorize. Number 1, I'll repeat again. Look what happened if aluminum is there. If aluminum is there, white precipitate dissolve. If lead is there, white precipitate dissolve. White precipitate dissolve. Calcium, white precipitate does not dissolve. Copper, blue precipitate does not dissolve. Iron 2, dirty green precipitate does not dissolve. Iron 3, red brown precipitate does not dissolve. Chromium 3, green precipitate dissolve to form a green solution. And ammonium ion, we add sodium hydroxide and heat, a pungent gas given off, which is ammonia. I give you the reason, like example, when you have an alkali with ammonium salt, they will always give off ammonia. So whenever you want to test an ammonium ion, NH4 ion, what you will do, you will add sodium hydroxide. When you add sodium hydroxide, it will give off pungent gas, which will turn red litmus paper blue. And the gas which is released refers to ammonia. Chromium is +3. So you have to memorize, learn this table. So how you will use that we'll discuss, but first I will give you a week time to memorize this table. This is one of the tests. You can test the positive ion by aqueous ammonia. Then there's also another test. You can also test by first was aqueous sodium hydroxide. The second one is aqueous ammonia or ammonium hydroxide. It's the same thing. So what you will observe if you do the same test by using, instead of first you was using sodium hydroxide. So now we will test. The second way we can test is by aqueous ammonia. You have to memorize everything in this sheet. So second one, aqueous ammonia or ammonium hydroxide. First, I want you to memorize. Once you memorize, like next week, we discuss questions related to this topic. But first thing is memorization of the test. Now, same way, using an aqueous ammonia, you can also test or identify. If you have aluminum ion, you add 5 drops of ammonium hydroxide or aqueous ammonia, you observe white precipitate. When you add an excess, the precipitate does not. These are the tests to find, not ammonia, these are the tests to find the positive ion. Tests to identify the positive ion. In exam, they may give you the ion and they mention the test and you have to identify what will be the observation. Or in exam, from the test and observation, you have to identify which positive ion is present. So if the positive ion present is lead, you add ammonium hydroxide. If you add ammonium hydroxide, the precipitate does not dissolve. So same thing with aqueous ammonia. With aqueous ammonia, aluminum and lead give the same result. So we cannot distinguish between them. With aqueous ammonia, we cannot distinguish whether it is aluminum or it is lead. So when we add 5 drops, we observe white precipitate form. When we add an excess, the precipitate dissolve and it will form a colorless solution. So in this case, if a white precipitate and it will dissolve, it shows that it might be aluminum or it might be lead. Both can be there because the result is same for aluminum and lead. But if zinc is there, if zinc ion is present, it will give a white precipitate. But when you add an excess, the precipitate dissolve and it will form a colorless solution. So when it will form a colorless solution, so you can identify you will identify that the zinc ion is there because it formed white precipitate and the precipitate dissolve. Then with calcium there is no reaction, no visible change. With iron 2, green precipitate does not dissolve. Iron 3, red brown precipitate does not dissolve. And chromium, green precipitate dissolve to form a green solution. So basically, how you will use this test, I will give you a question. I will show you the questions from the exam paper, the past papers. Then you can identify how they will ask the question and how you will use this table. Just a minute. Can you see on your screen? Test, salt and identifications. Okay. Now how we will use, okay, how the question will be there. This is a question actually from the exam paper, the past paper. You have 2 salts, F and G. So there are 2 salts, F and G. And were analyzed. F is iron 2 nitrate. So they give you a hint. They give you that the name, this F is what? It contains iron 2 and it contains nitrate. So there is a positive ion and there is a negative ion. You have to learn the test for the positive ion and you have to learn the test for negative ion. Sorry, iron 3 by mistake. I said iron 2. It's iron 3. Is it okay now? Two salts F and G were analyzed. F was iron 3 nitrate. So iron plus 3 is there and nitrate NO3. Solid F was dissolved in a distilled water. We dissolve first in a water. And the solution F was divided into 3 equal portions in the test tube. So like you have 3 equal portions in the test tube. So test tube 1, test tube 2 and test tube 3 all have the equal portion of iron 3 nitrate. Few drops of aqueous sodium hydroxide were added. If I add sodium hydroxide and I have iron 3. So if I add sodium hydroxide and I have iron 3, what is the observation? Iron 3, sodium hydroxide is added. You can see here, this is test with sodium. You can use this table now because you did not memorize and you have iron 3. Yeah, red brown precipitate, that's good. So what we will write here, we will write red brown precipitate. Precipitate, you can write PPT. Next, an excess of sodium hydroxide was added. Excess means like more than enough, too much is added. So if I add an excess or too much, what I will observe if iron 3 is there? So precipitate does not dissolve. So what happened when we add an excess, some of the precipitate dissolves, some of the precipitate does not dissolve. The precipitate does not dissolve. So how you can answer this question? You can only answer this question once you memorize the table. This question cannot be answered without memorizing the color of the precipitate for different ions. Same way, is it clear to everyone how the question will come related to? Same way, then there's another test. So next part, an excess of sodium hydroxide was added. Excess of, so we did that, and then excess of aqueous ammonia was added. The second part here, if we add an excess of aqueous ammonia, what we will observe? So when we add an excess of aqueous ammonia, what is the observation? This is if iron 3 is there. Again, it will form a red-brown precipitate which will not dissolve. So it will form red-brown PPT, which does not dissolve in excess. I will solve more questions with you, but first I want you to write the test for the negative ions as well. This is the test for the positive ion. Now there will be a table for negative ion which you have to memorize as well, and then collectively you will identify the salt. So test for the positive ion, there are two ways you can test. Number one, you can add sodium hydroxide or aqueous sodium hydroxide. Test by 5 drops or excess of sodium hydroxide, or the test number 2 is five drops of aqueous ammonia. Yes, sodium hydroxide is a base. The hydroxide of aqueous ammonia is also a base. Both are the base. No, we don't have to separate the ions. When you make a solution, ions are separated from each other. Like when you make a salt solution, if I say I have a salt, example sodium chloride or aluminum chloride. So aluminum chloride is a solid, but when I make a solution, I dissolve this in water. So aluminum ions are separated. That's how the dissolving occurs. Ions are separated from each other. Aluminum ions are separated and chloride ions are separated. So then we will do a test in this mixture, a salt solution. We'll add 5 drops of sodium hydroxide, then excess. This is a test. This is a test for the positive ion. These two tests, there are many ways to test the positive ion, but in your course outline, you have to learn two of these tests. One is by sodium hydroxide, another one is in aqueous ammonia. As you will study, like in A levels, you will learn different types of tests. This is according to your course outline, you have to test the positive ion by sodium hydroxide and learn the observation. Same way you have to test by aqueous ammonia or ammonia solution and learn the test and observation basically for different ions. For negative ion, why I did not write, for negative ions, why I did not write the specific test, because different negative ions have different tests and you have to memorize all of them. So because it's a variety, so that's why I did not write. I will mention now. First, copy this part. So for negative ion, there are different tests to check the negative ion. So what you have to learn, you have to learn a test for chloride carbonate. You have to learn how to test a carbonate ion, chloride ion, bromide ion, iodide ion, sulfate ion, nitrate ion, sulfite ion, SO3 with a charge -2. So these are the tests you have to learn: carbonate, chloride, bromide, iodide, sulfate, nitrate, and sulfite ion. There is a lot of memorization in this. The best way, if you want to keep this or memorize, it's not like just memorize today, you will forget. So what you will do, make a habit like revise every day, give 5 minutes to this part so that you will revise every day this sheet or test for each ion, so that you will remember for a longer period of a time. Only if you give only one day for whole memorization, and then if you did not revise, then you will forget the test. So it's better, the best way to learn this is just give 5 minutes to this and memorize every day. This is sulfite. The last one is SO3 sulfite. This is called sulfate. And this one is called sulfite. I will write the test for each. Carbonate ion is CO3. So what is a chemical test for this carbonate ion? Test is add any acid. What is the observation? What you will observe? You will observe fizz, bubbles, or effervescence. Or colorless gas, which can turn lime water milky. So what is the observation? So basically, whenever you have a carbonate, you can add any acid. If a salt contain a carbonate, say I have a container, and in this container I may have any positive ion, but the negative ion is carbonate, CO3. So what I will do, I will add an acid. When I add an acid, what is the observation? What I will observe? I will observe bubbles, fizz, or effervescence, and these bubbles will turn lime water milky, because the carbonate lime, if we test with the lime water, if a gas is tested with the lime water, it will turn lime water milky. due to because it's a carbon dioxide or CO2, that's why the lime water will turn milky. Yeah, you can test with any acid. You can add sulfuric acid, hydrochloric acid, nitric acid, any acid. You will observe fizz, bubbles, or effervescence, and the lime water will turn milky. Copy this. Yeah, I'll share another link.